Welcome to the Power Up Podcast. This is a bonus episode of our series on artificial intelligence in the electric utility space. Now, this episode came out of our conversations. We tried to do this in a 3-part episode series, but turns out we needed one more. So welcome to this last bonus episode. And once again, joining me is Anthony.contino from SBS, Ben Favreau from Black Veatch, Cory Byrnes from Beta Engineering, Josue Sanchez from Quanta Technologies, Michael Bussinger from Burns McDonnell, and Shawn Weekly from Power Engineers. And I'm your host, Trevor Scullion. Now we're going to pick up right where we left off with Cory Byrnes talking about safety and compliance issues around AI. Take it away, Cory.
There are plenty of podcasts that are out there that go over safety and compliance. That's all they are dedicated to. And I would push back a little bit, Josue, with regards to whether this is kind of the same thing, just a different form. And to be honest, I think AI opens a lot of safety and compliance challenges that frankly weren't there before. And yes, some of the same fundamentals certainly apply with regards to access requirements and allowances and third-party vendor evaluations and SOC 2 compliance, things like that. But the avenues for security breaches and safety breaches changes dramatically. And I think the number of opportunities and avenues upon which you can have security information data breaches really grows very aggressively. And as much as I think ideally the world is going to, kind of drop those barriers and kind of, as Shawn, as you noted, the utility industries of the world or the utilities of the world are going to kind of open up more and say, all right, we've got these great ecosystems to, share and analyze data. In my honest opinion, I think those silos and those walls are just going to get taller, wider, deeper, and much more reinforced for all the reasons that there's already inherent security and data challenges and risks associated with that. So with all these increasing avenues of security compliance challenges, there is going to be a dramatic focus, I think, an increased focus on safety and compliance.
Yeah,
Go ahead.
You don't need to be someone who's been versed in cybersecurity for years anymore. You can work with an AI agent to learn how to be a new script kiddie and figure out, like, you're going to have people who never would have tried to do anything with the substation before from the outside who can just, they're bored. They're going to go say, hey, can I go do something with that? Figure out how to get one of the AI agents to help them write something to then go and try and take down a substation on the corner of their neighborhood or something, just because they can. That's not something that we've ever really had to worry about. The barrier for entry is lower and lower every week for just learning how to do new malicious things. So I agree. I think those borders, the silos walls need to go up higher and higher, but they still need to use these. We still need to use these tools in the industry. So we still need to digitize that data. So and we're probably going to get into this in the next couple of topics, but I encourage everyone, at least in this call, to look into like the NERC sites subgroup that's working on cybersecurity with AI.
Yes.
If you participate in that, that would be something that would be good. We need more knowledge. Well, we don't need more knowledgeable people per se. I feel like everyone in that call is either getting their doctorate or advancing on their master's degree in something with AI. And I'm just like, I know what AI means. So it's definitely humbling to jump into that call, but I think y'all have good input, good real world experience with how we could use these things and how they could be abused. So
Yeah, there was a good little nugget of advice there. I think both Cory and Anthony touched on, being able to talk to your vendors potentially when you're doing any kind of AI project, that reporting, and Anthony called it reasoning, right? The reasoning between agents, if you're doing an agentic AI or something, being able to see how it came to its conclusion is a critical piece of it, right? Because you go to ChatGPT, it's like a highly paid consultant. It makes stuff up. You don't know how it got there or what it did. You have to be able to go through that reasoning and log it and we need to see it, especially on our side of engineering side. I mean, we need to see it. We can't do the typical kind of, we're not poetry writing chat GPT, write me a song like Tom Petty. I kind of need to know how it got the answers, right? So yeah, that was a good little nugget you dropped there for anybody looking at doing an AI project and talking to their vendors or third party. So all right. So we talked about this briefly, but let's get into the skills and what engineers are going to need. I'm curious to see what you guys think about new roles. I think Cory touched on it. I think Shawn said something about that. Like it's to have our engineers out there that are interested and obviously want to keep upskilling themselves. What are they going to need to know, and not just prompt engineering? Do you think they're going to need a level of kind of machine learning understanding, and what kind of new roles do you think are going to come out of all this AI use? And let's start with Cory.
I think I definitely think there's going to be some new roles that come out, and no question, in my personal opinion, for somebody coming into the industry new and young, I would strongly encourage you start to investigate avenues with regards to learning some basic coding language. I've mentioned this previously in this episode for sure, and even in some of the other ones. With AI being so good at writing code, you don't necessarily have to be a professional at writing code. You don't have to know Python, JSON, all that stuff. You can really work with an AI agent or even just a standard AI right out of the box, ChatGPT, just go to the website. You're not letting out confidential information by just asking it, probing it, hey, can you write me some code for this idea? You're totally safe doing something like that. So I think skills wise, I think we're going to see industry wide in our industry and virtually every industry, understanding, at least being able to look at code and read it. It's almost, for most people, coding is a foreign language. For some people, they're fluent in that foreign language. For other people, they just know how to read it. For some people, they just know how to hear it. This is going to be one of those circumstances you don't have to be fluent in it. So that's a skill that I think definitively we're going to start to see increasingly more of at just organic development of in our industry, as AI continues to have a broader and broader impact as far as that's concerned. When it comes to CAD, and the implications or applications there, again, I noted I think the development cycle for new tools and plugins and things like that is going to dramatically change the landscape of that. So I think for a lot of CAD individuals, be open, and especially managers, CAD managers, be open to, hey, what kind of really inexpensive tools are being developed day in, day out to kind of automate and accelerate some of what we do here. Do we even need to be manually dimensioning anymore? Those kinds of questions of why are we even manually creating sheets and creating views on those sheets? Is there a way that we can just tell the AI agent within this software on every project, I want to see, orthographic view, and I want to see an elevation here and an elevation here. And every time we do this, do that. Those kinds of automation capabilities. So at the very core, and this may be a broad-based kind of way to close this out, having an automation mindset is, I think, a skill that is going to become extremely valuable for new entrants and even current employees at companies of, hey, how can I automate this? Because in my opinion, engineering is, especially in our space, shifting a little bit from, hey, how can I design this and build this, to, hey, how can I automate designing and building this?
Yeah, that's good. Yeah. I mean, you think of the times when we went from drafting tables to CAD systems for the older guys you talk to. And, they went through this whole learning curve of like, it couldn't look like a hand drawing. It just couldn't. You just didn't want to do that. And here's why. And they had to take this time at least to understand the CAD system, even if they didn't want to. They did take the time to understand how it all worked and see it come together. And yeah, I think we're going to have to do quite a bit of that with some of the AI tools. But Shawn, you want to weigh in?
Yeah, I have a little bit of a different thought process here. I think we need for, I've said something like this before, our engineers to go back to the engineering aspect of what they do. I think that at some point we're going to get real good at automating and shaving off the edges of all of the CAD tools that we use to make them easier. It'll become, route or routine for the CAD and design part to happen, and maybe an AI does it, right? But what that means is that, until we have AGI, if we ever get there, and until we trust that to actually do design, then our engineers will always be in the loop to check this stuff. And if they're not doing that today, then they need to get back to doing that. They need to get back to knowing the math. They need to get back to knowing why that connector is used for that wire on that piece of equipment. Because, the systems will generate drawings, but it's not going to know if it's right. And if we don't have people who really know the why, then we're going to screw ourselves. and it's going to be terrible. And we need to get back to the basics. We need to get back to engineers doing engineering and understanding the whys, and not having to, they go to school and they learn engineering. They barely touch some of the CAD tools, and then they come into a design group and now they have to learn how to do CAD, and the engineering aspects atrophy. That's what probably scares me the most.
Yeah. It's funny. I met a lot of salespeople in this industry that, work for some of the vendors selling equipment, and they're all engineers. And they got into sales because of the commission-based revenue and everything. And they haven't practiced engineering in, 20 years. Haven't even looked at it. Anybody else want to weigh in on that?
I do
Yeah.
actually, before I let everybody go, I do want to dovetail that, because I want to say that I agree wholeheartedly with what Shawn just said. Well, I think automation is going to be a big role. At the end of the day, it is absolutely critical that we maintain competency in what we do.
The other portion, and adding to Sean's comments, is, and I believe we already have similar approaches. Talking about P4A, for example, or AUD in the distribution or transmission side, that configuration that SBS built related to the violations, that check-ins to if meeting a voltage drop, or if it's meeting the depth of a pole on the ground, right? I look into that in the same concept of it will, if the hardware will be upfront, and that's where the engineering will be applied. If you can make sure of those, which we already do, because we have the standards, we have the calculations. I mean, we rely on spreadsheets for complex voltage drops. I mean, analysis. If somebody mess one cell, if you didn't log it, then you will be, as an engineer, you will be approving something that it's not right. That's why I am very positive, because we already have some kind of a framework, which in this case is P4A, using the violations concept. But now you can enhance it with AI. Now you can say, an example, P4A doesn't check for NERC compliance, but with AI now you can add a concept, an AI agent that will check for relays, or maybe relay settings, maybe relay contingency or backup, and we'll tell you, hey, based on the rule NERC 1234, you are missing one relay here. Oh, I didn't talk about that. So, right. And a human person, I believe, if you leave it as a regular approach, like you send the drawings to another person, to maybe an engineer, PE, to review it, well, maybe he's a human. He can miss that. Now you have something already taught up front that is part of the violation framework, and can do the weights check and the compliance check, and maybe blend it into, I call it the violation, but yeah, it's a kind of a checkpoint again that will advise you if you are in violation of any kind of a safety or regulatory compliance point. So I don't think that we are that far in terms of the concept, because we do already something similar. In this case, with the violations framework that P4A have. I just want to add that. Yeah.
Yeah, that's good. I love the reference to the spreadsheets, right? All those spreadsheets sitting out there.
Yeah.
The
Yeah.
endless amount of spreadsheets.
With code and everything, and just you have to. I mean, if you are a new engineer in an engineering firm, what you are going to do is you have to kind of trust it and do them. You have to do the calculation yourself, and okay, yeah, it's working fine. Or you didn't did that, and you are assigning something that is not totally correct.
You got to realize that the entire U.S. power grid is held up by one substation maintained by one engineer somewhere in the Midwest that's going to retire in 9 years, right? The entirety
smoking a cigar in a chair.
You're not supposed to say that out loud.
Oh, I'm sorry about that. Yeah, we can edit that.
All right, that'll be the next episode, the dirty secrets of the grid. Speaking of dirty secrets, let's go on to cybersecurity again. I just want to close it off with, because you mentioned DeepSeek, right? And that, it's China came out of nowhere, apparently. I mean, I saw R1, it was pretty dumpy a couple of months ago, but the new one is powerful. I put it installed on a Docker, and it really makes you start thinking of what kind of malware could be buried inside this thing. It's 156 gigabytes for the light parameter one, so it's not small. And you can download that thing, get it running with like Olama, run it locally. There's got to be some scary stuff that's going to be floating around inside this thing. So let's start with Shawn. Shawn, you want to touch base on this?
A little bit. I mean, we talked a lot about it before, I think. The challenge here is that, because we don't have a lot of folks in the utility industry that know programming all that well. I mean, we do, right? But they learn it as a secondary thing.
Right.
They're engineers that learn how to code and all that. So you don't get taught the traditional or semi-traditional paths to securing code and things like that. We also, because you're not really focused on the guts of it, maybe you're not looking at the code, maybe you're not learning how the code works. You're taking somebody else's word for it, right? And that's a dangerous place to be. That's complacency. That C word comes back up, and I can't stand that word, because that's what we do. We get lulled into a sense of complacency, and then we allow stuff to slip through the cracks. And that's exactly what nefarious actors are waiting for, is for you to get complacent so that they can jack your system up. Now, the flip side of that is that we should not be so paralyzed by fear of cybersecurity stuff that we don't do anything. Because let's face it, there's a lot of ways to take down a substation that has literally nothing to do with a computer unless you throw it into the substation across the bus or something. There's a lot of things that require no technical skill that could take down large portions of the grid. But we still operate the grid, and we still do things to mitigate that. So we need to do the same on the cybersecurity side, and not just say, thou shalt not. We need to say, thou shalt within these parameters. And we need to just come up to speed on basic cybersecurity stuff, OWASP 10 and all that. We need to get better at that.
Yeah, Ben, what was the name of that NERC group that you said again?
There's a NERC sites AI/ML subcommittee that's currently analyzing use cases and kind of advancing a white paper they had already made on AI/ML in the substation industry and the grid system. So,
I
encourage people to reach out.
Yeah, I know we talk about a little bit before too, but I believe this is the where the AI will receive, especially in the electric utility industry, it will receive the main pushbacks from many sides, from the PNC operation folks, executive level, their compliance officers, and you name it, because it's a no-no to have your obviously substation configurations. It's all the details kind of online. You may find some, but it will be is right now it's very hard to find how a substation in a specific utility is configured and how communicate and what point to what point. But at this level of data that you have to share with the AI, and you don't make sure that is really secure and it's not really accessible to external entities, or in this case hackers, right? You will be exposing obviously all your configurations, and nobody wants that. So uh, acting as a devil's advocate, me in an executive level, knowing maybe little about AI, but knowing all the aspects related to cybersecurity and their compliance and maybe the dangers that could represent somebody accessing your, just to know how your system is configured. What is your IP address and how is the firewalls and what brand of equipment you have? You have that in the standards, and having that, I believe this will be the main question and the pushbacks uh, from not only one side in the utility industry, from many points. It will be shooting the initiative. So yeah.
I'll counter argument that just a little bit. We already make sure that we store everything because all that information right now is stored in our systems, right? It's not available to an AI because we don't have those available, but it's all there. So if someone wanted to get to that AI that we have inside of our system now, they'd still have to go through the same processes that they would to get access to all that information currently. They'd still have to hack in, pitch someone at the company to then have access to everything that we have access to on an individual level. So it's just making sure you have good internal cybersecurity. Like if you're using Windows, have it set up so that everyone has a certain level of access, but no one has access to everything. That's how, like, I only have access to certain files that are relevant to certain parts of my job. I can't go and look at every single client's substations for the last 50 years. I could probably go and do some of it, but like that's not easily accessible to me at the moment. Without just jumping through and individually going through thousands of files. Yeah, AI would be really good at that. But again, limit who has access and keep it not just by like physical access, but real cybersecurity access. That's why we have to, like, as engineers and technicians, we have to rely on our IT departments significantly more for this type of stuff because no one can know everything. No one can be an expert in every field. Engineers should engineer. Like we have drafters who should know the software and draft. We have IT folks who should know the IT and make sure that whatever we're doing, let the AI people focus on the AI. Let the cybersecurity people focus on making sure that it is siloed off enough that we don't have to worry about bad actors coming in because that's their job. Let me just figure out how to use this to accomplish our jobs faster. So trying to head off any fear from the C-level folks, just you have experts for a reason. Let them be experts in their field. Cybersecurity is going to be just as important now or more important on top of all the engineering. So
yeah, that's for sure. Absolutely. All right, let's move on to some more fun stuff. Now, originally, we were going to try to forecast the next 10 years. or 5 to 10. We scaled back to 5. I think that's more realistic, seeing as shit's changed so much in 3 months, and I don't think we could do 10 years. So I'm going to start with Michael. Michael's been politely waiting in the wing there, but he's like, looks like he wants to talk every time we're having a discussion. So let's say, Michael, let's talk a little bit. Let's, anything you see coming, what do you think, predict what would flip substation design on its head? Smaller station automation or anything you guys are working on?
Yeah, I mean, definitely smaller station automation, generative design with it, of course, but I think you could essentially get it to help you develop some of your initial packages a lot more quickly and efficiently. Your 30%, 60%, maybe not in the full scope of it, but definitely get you a great jump start on it. Also, kind of in that 5 years, I think other things I was kind of looking up a little bit before this, like energy efficiency, the renewable energy integration side of it. I think one of the previous questions that we had listed that we didn't have in here was kind of like being able to predict blackouts. I think integrating AI into things, it could have some predictability in it and help plan for potential future outages, maybe load in specific places where potential utilities aren't seeing a big use case, but data centers are getting put in all over the place now. Where do we need another substation? Where do we need more energy to be delivered to, or what's the most efficient way to do it? I think there's a lot of potential there, probably within that 5-year time frame, considering the developments that we've seen in this short window so far.
Yeah, it's pretty interesting. We're talking about AI, and I don't think we have enough energy for the next 5 years to feed all these data centers, right? So,
definitely not.
Yeah, no kidding. All right, how about Cory? You want to chime in here, bud?
Yeah, I think Michael, a lot of what Michael just said is absolutely going to be the pathway, specifically with regard to generative design and AI generative design. But in my honest opinion, in the near term, I think a lot of the innovation, or at least a lot of the excitement that you're going to see, even if it comes from the traditional institutional third-party vendors of the Autodesks and the Bentleys, and is some of the generative capabilities and automations that are going to start getting baked into those those tools, whether it be things like automated analysis modeling creation based off of physical modeling. Things like that is going to accelerate these workflows that we currently have, to almost get to that end-to-end design process. Certainly it's going to start at the smaller substations, but I think it's going to quickly evolve into these larger substations. I think more of what, from the engineering side of things, because that's where, my world predominantly lives, is I think modular substations have a huge potential in kind of the AI age, so to speak, and being able to, one, quickly manufacture modularized substations and kind of really identifying, hey, we can not only make this modular, but we can customize it very simply and create a 3D digital model that can then be sent over to CNC machines for automated manufacturing on a quick time scale and a quick turnaround circumstance. And, we can go from first point of communication to installation in short periods of time. I think that has real opportunity potential in the kind of, call it digital age, not even necessarily just the AI age, but especially gets accelerated with the opportunity of AI.
Nice. Anybody else want to weigh in on any predictions? This is your chance to say you knew Clippy was coming back.
I think something we haven't talked about is AGI, artificial general intelligence, right? I mean, everybody thinks it's coming eventually. Will it be within 5 years, 10 years? I have no idea. But I think that's on the horizon, and it's it's the next step before we reach singularity in ASI, right? If artificial sentient intelligence is going to be a thing, we could be living in a completely different world, right? So, like you said, everything's changing so fast, and what we're talking about today could be completely null and void in 5 years, right? The whole landscape could change, and maybe we don't even have grafters or designers or engineers anymore. We really don't know. So it's tough for me to say where we could even be in 5 years with how fast these things are moving right now. Um, going back to the energy requirements, right? We have Microsoft turning 3 Mile Island back on, Google building small scale nuclear reactors to power their data centers. So, they see the future. They see what's happening here. They have probably more data than we do to go off of to make the decision to turn on an old nuclear reactor like that, because that is not a small investment to do, right? And they've convinced Constellation that it's a good investment. So there's a lot going on that I think is going to change within 5 years. Doesn't really provide any answers. Sorry, I just think there's a lot of unknowns.
No, that's great, man. I love it. It's awesome. And it's funny, like I have this recurring dream with, every time I see augmented reality glasses, right, getting better and better and mixed reality, just are we even going to need drawings? If you can just put on safety glasses and see dimensions physically in front of you in a state, like, do you even need a drafting? I mean, just who the hell knows? And it's coming so
Yeah.
fast. I mean, shiny object. What are we going to work on next week? You just can't turn it off. All right. Any other predictions before we move on to some ROI? Because I'm sure if we have any manager or executive listening to this, they're thinking, show me the money. That's it. So we're going to invest in AI today. What kind of payoff should we expect, 5 years or, is anybody, I mean, do you guys have any case studies now? I mean, have you seen anything like a real case study of somebody implementing AI and improving their design processes or anything right now?
We've seen a lot of improvement of design processes for sure. But I think where you could get a great ROI, kind of going back to a previous part of the conversation where everyone was saying, engineers should go back to engineering and the CAD should do the CAD. It's like we actually need to look at developing your traditional CAD staff into more of a designer entry level engineering role. Because at that point you can then get the same output from someone who doesn't cost as much for non-PC way of saying it.
Sure.
But it's kind of twofold though. The school, like we need to find a way for the Autodesk and Bentleys of the world to help these schools better educate the staff on the programs that are actually getting used in the industry. I used to teach for 5 years at a community college here, and a lot of my staff, I would teach what the school wanted me to teach the students, but in my classes, I would give real world examples of exactly what it was that I did in my field, and it's really. I'd say it's really nice to see a lot of my students walking around the building here and knowing that they're doing well where they are. But I've had several of them come up to me afterwards and say, you're probably one of the only teachers that actually prepared me for what it was we were getting into in the industry, because they're still getting taught how to draw squares and circles. For what? That's not what we do, at least not in the utility space. So sure. I think that's kind of a long-winded answer, but I think the ROI is actually going to come from better developing the people that we already have. There'll be new roles and things like that, but some of these people are a little afraid in some instances about AI coming in and what that may mean for job security. Adapt to it. Nobody wants to see the reduction in the workforce. So let's help you better educate yourself and get prepared for what's coming. Because to the point of the AI people need to do AI, engineers need to do engineering, drafting needs to do drafting. Sure, but what if the engineer wanted to go study AI and now you have this dual-edged sword that of a person that's just going to be a rock star for your company. So that's kind of long-winded answer to that.
No, that's a great answer, man. I think that's a great answer. And I think like Anthony and I, building software for Autodesk products, I think you're going to see the complexity come down, right? I mean, you look at something like Autodesk Inventor, Revit, I don't think most users use, they probably use 30% of the functionality that's in a Revit or Inventor. They don't use every little aspect of it, depending on what industry you're in. I think they're just going to be removing more and more of that, especially as the AI comes on. It can help more on the small mundane things like the drafting part and all that kind of stuff. To me, it's not giving up jobs. I think they just focus, like you said, on design. Isn't that more fun anyhow? You get to build new designs and things,
I
not
think
worry about
so.
cleaning up draft. Yeah. I don't think we need to stretch and erase anymore, right? We'll
No, I
get rid
mean
of that.
it's nice to get something where you can put your headphones in and kind of drift off and get things done. But there's nothing better than just a challenge of a project, and then at the end of it, you've learned so much in the course of that project that you better yourself, but also helping to get that company one step further. So. Then
Yeah.
I really like the site visit aspect of what we do, going and actually seeing what it is that we build. That's real gratifying as well.
Yeah. Right on.
So
Go ahead, Ben.
as the drafter who learned design, I completely agree. Even though I was the one who said let the drafters draft and let the designers design. That goes against everything I'm doing right now with teaching my drafters how to do rudimentary design as they're learning all of the BIM tools with SDS and stuff. So, yep, I got proved wrong by my own words got thrown back at me and being wrong. So I completely agree with you, Bus. Like that is 100% on board with that. This, some of the challenge though is that we're seeing fewer and fewer people get into the drafting industry. So it's either stagnated or declined over the last few years. So it's finding people where we can at this point, or automations where we can, or AI where we can, because we just don't have resources anymore to do the work. I think at last SDSIC is Kevin Ludwig's presentation. He talked about there being almost 8 gigawatts of solar power being proposed over the next 30 years. That's going to require over 2,500 collector substations and like 1,200 integration substations to take all that power and put it on the grid. So that's a lot of substations, and we don't really have a lot of people to do. So we need these tools. We need AI. We need the automation to help speed up just getting these things designed and kicked out the door with quality in mind and safety in mind. So, yeah.
At the end is the productivity. I think is if you can align ROI based on productivity, I believe everything around what you are planning to do, it will target and improve the productivity. And with the productivity, many things will be positive as a result. You know what I mean? It's if we can be able to increase dramatically the productivity, you may don't need to hire what you had planned. Maybe you had planned to hire 50 drafters or designer. Now you may just need to hire 10. There is an ROI there. And so on. I believe everything around the productivity will be the main point of benefits. For sure, will be more, but the productivity is the main deal here, in my opinion.
Yeah. Excellent opinion. Yeah, I think you're right. I mean, definitely if you're trying to, get approval to hire or purchase or do anything, any kind of project at all, right? It's always productivity, right? Everybody wants to know, are we going to get more done in less time or not, right? So, let's go on to collaboration. We talked a little bit about what to look for in some vendors. Talk about like anybody have a dream team collaborator? You want to do a shout out to any vendors? Anybody working with any universities or any of that stuff? And let's start with Anthony.
Well, I don't have any shout outs to give, other than to SBS, obviously. But I think utilities partnering with different AI vendors, it's going to be paramount to their success, right? They don't, utilities and AEC firms, they don't have typically software developers that work with them. It's, engineers, maintenance, that, they're worried about the utility and, overcoming those technical, regulatory, and safety barriers we discussed earlier, while still handling the day-to-day operations of the utility is going to be their goal here. So, let utilities partnering with AI vendors or software providers. It allows them to, use their data that they already have, work with the AI vendors, data scientists or AI engineers to go through their data and say, hey, here's what we can do. Here's where we need to make improvements. And in addition, it helps them develop, the data gathering that they would need in the future to support new products and solutions coming out that they could support them with. Some of these would be predictive maintenance, maybe grid optimization. So it's working with a team that understands the AI world, right? There's a lot of vendors and software providers out there right now that just want to throw AI on something. So you have to vet who you're working with a little bit here to make sure that they truly understand the needs of your organization. Going back again to data in, data out, right? If you don't have that good, clean data going in, your solution output's not going to be very usable. So working with a vendor who has good data scientists and understands how to clean it and how to store that data will be paramount. If some of there's We talked a little bit about NERC, I think, consortiums and other organizations like EPRI and IEEE and other working groups. They're starting to focus on AI applications in the power systems world, which is great, right? That's what we need. We need to develop these standards so that these AI vendors and software providers can ensure their product meets the requirements of a utility. And standardizing it allows you to develop software not just for one utility, but for every utility in the industry that can follow this standard. And this relieves some pressure off the software providers themselves. Now they don't have to try to build a solution for every single utility that meets their specific requirements. The utilities will be able to adhere to the already approved standards that IEEE or NERC or EPRI come up with. So I think standardization in this space will be a welcome addition to everybody.
Awesome. Thanks, Anthony. Shawn, go ahead, man.
So I wanted to touch on something here real quick, and it actually ties back into the previous question about ROI. First thing I want to say is that I think that it's okay to not have any expectations of ROI when looking at some of these particular solutions. AI changes so quickly and it changes, on foundational levels to the point where if you've got somebody that can come to you and say, if you use our AI, it will save you 50% of X. How do you know that? Where's your empirical data that says you can actually save 50%? That needs to be proven. And so I think that the utilities would be really well served by having to put a little money in to do some of this research themselves. And that's where it ties back into these partnerships, right? Don't be afraid to work with a partner to determine whether you're going to save money or not, to determine whether the solution they're going to provide is actually going to work. Because if you go into it with the expectation, or if you drink the snake oil and expect that there's going to be X amount of dollars saved over Y time or whatever, in a lot of ways that becomes a barrier to entry, and you just won't do it, especially if it's operations and maintenance money. And if it's not capital money, then they just won't spend the money, right? So I think it's really important for there to be an openness about this and understanding that this is new. It's changing every day. And sometimes you just have to step out there on the plank and, take a big old nosedive and hope there's not sharks there. We need to do something besides nothing. We don't have to be, we don't have to necessarily be forward thinking, super innovative type industry, but we should at least move away from the status quo.
Right. Yeah, it reminds me of like Peter Thiel, when you have a startup company, so it's like jumping off a cliff and assembling the plane on the way down. That's how I feel about all these AI projects. Just jump and figure it out on the way down, because nobody really knows the answers just yet, right? So,
Right.
So Shawn, along those lines, and I know you and I have talked about this, and this is probably a good team to kick this off. We talked about having an open source project in the STS consortium around, even if it's setting standards for AI tools, maybe it's setting standards for what that data engineering needs to look like. Maybe it's, I don't know, standards around what data do we actually need and in what format, something
Yeah.
to help them along, but keep it as open source. Let's call it closed source, where if the utilities participate, they could use the source code or whatever. Yeah, I
Yeah,
mean,
we talked about this, and I really want to push this further. It's kind of stymied on us. It would be really cool. We have the consortium, the SDS consortium. What if, and this is not approved, so don't a whole bunch of people start saying, hey, let's do it. But what if we opened up some form of registration to say, hey, if you're a college student or a new engineer or something, go design a substation. Here's your environmental requirements, because that's really what's important, right? Where in the world is this thing going to be built, and what's the environmental conditions for this substation? And here's here's the voltage coming in on the high side, here's the voltage coming in on the low side. Design a breaker and a half substation, or design a 4-bay, whatever. I'm not a substation guy. Let's say we open that up to the consortium, and you say, if you design a substation and it passes QA/QC, you get to come to the consortium for free. But we're going to use that data, and we're going to come up with some really cool tools with that data. If we could do something like that and get a bunch of data, that would be freaking amazing, because that is the biggest stumbling block we have today, is a lack of data. The utility companies don't want to give it up. They don't want us to use their data to do that work. So let's just create our own. And it doesn't have to be fabricated data. It can be really done by real engineers. It just doesn't have to be at an actual place, right? Somebody can come design a substation and put it in my backyard. I don't need a substation in my backyard, but if you could, use my backyard as the plot of land, that would be cool. How awesome would that be if we could do that at the consortium level?
John wants open source interns. What he wants.
open source interns.
Yeah. Yeah.
I like it.
I agree. It's getting around that NERC security compliance stuff. Why utilities don't want to give anything away. And that's makes sense. That's their industry on the line. So
we need one to go first. We just need one.
Need someone to hire out someone to design.
Yeah, I mean,
Well,
the regulated not the regulated, the renewable companies, right? The folks who are building these renewable sites and stuff like that, they don't have these problems. They're not regulated right now. They don't even in a lot of cases, if it's my understanding, they're not even utility companies, right? They're developers.
Right.
And they're asking us to come in and design a collector substation or something like that for a solar plant. And they don't have any standards. They don't have any best practices. And they're coming out of industries where it's commonplace for data to be shared back and forth. So, if the big regulated utility companies can't do it for whatever reason due to regulation, these renewable companies could.
That's a good point.
Well, at the end, the what we do in the utilities is in general is the same in Florida and in Alaska or New York. Mainly, and I am engineer, but I don't want to sound that I am diminishing myself. But we do a lot. Engineers, we know we do basically or deal a lot with a lot of formulas, meaning translated to standards or specifications, and many is a double boss in Florida is the same double boss in New York. It maybe have some different specifications because of weather or things like that, but in general it's kind of it's reading in the books since the 70s. So standards and there is a lot of documentation that is completely available that will allow to do a small design, maybe a ring boss,
Mm.
transmission ring boss, and maybe a double boss in distribution. Well, that's a common standard. It's not a FPL or Duke standard. That's why I think that the initial conversation or the initial podcast episode, I mentioned it. This is information that is not really under any kind of NDA, because it's a general knowledge of
Mm.
a configuration, just using the configuration example. So it's not
Mm.
a proprietary double boss. It's not proprietary of a specific utility. Maybe the communication, maybe the backup or the contingencies, the logics. That it's maybe unique of a specific utility, but specifically the layouts and electric configurations
Mm.
is available.
So why don't we just task our committees to do this then? We have an electrical committee, physical, civil. Hey,
Yeah,
let's get an SDSIC substation designed. Like, doesn't have to do everything, but just a ring bus. Very simple. Well, in concept. Like, doesn't have to meet any client standards, doesn't have to necessarily have any deliverable drawings, but just let's get it designed. And then we can use that. I know that's not
Yeah.
necessarily part of this podcast, but like,
No, that's
why-
good. But let's get a meeting down for Chattanooga. Like, let's line it up and try to invite some people, and we'll get them in there, and let's have that conversation. See, we just need to figure out what we give them back in return, right? For
I mean,
the work to
Well,
put it
for the
together,
committee,
and
get experience, right? You
Mhm.
have a whole bunch of people that go to the physical committees and the wiring committees, and they don't know how to use the tools.
right.
Well,
Right.
now you got something to play with.
Yeah, there you go.
Go learn.
well,
Yeah.
electrical committee, we're
so
putting
is it
together a roadmap, like how
Yeah.
to set up an electrical project. We're already putting in the time and effort to do that in our project. Like, it doesn't seem like a big stretch to have a different subgroup from that committee to then wire up a panel, like
Right.
using these devices. Like, have someone tell us what relays to use. Okay, I'll go draft that, and we can use the PCS pre-built blocks that the electrical committee already made. Like, I'm sure the physical guys would love to model something and just throw it out there, like, or it's already on utility content. Like,
Okay.
a general session to bring that up to just, hey, let's build a substation so that we can start generating AI data from it that's not owned by any utility, so it doesn't have any sort of security implications, and it's designed by multiple utilities and firms together. So again, there's no single source of secrets coming out. Like,
Yeah, we could
outsource.
put it on a SDSIC GitHub, and people want to
Yeah.
use it, they can clone it and do what they want with it, and yeah.
See if
From that we can do obviously a white paper, and it's I will say that will benefit, and it's kind of in return to any utilities. I mean, I want to see that somebody else was the guinea pig. Maybe it was not a specific utility,
Yeah.
but was
Yeah.
a conceptual guinea pig, to put it in that way. Uh, and I now have the evidence that it is working. They are using these standards and they are meeting the cybersecurity and so on. Let's try a project now in our utility.
Yeah.
Right now many people had not seen that, so it's a guess decision. It's a risky decision to let's spend $500,000 on this project, and
Yeah.
if it doesn't work, well, we scrap it and that's it. But having a process already that a consortium went through, type of open source, and there is a white paper, and for sure many people will be interested.
I mean, you can
All right.
keep this in or cut it out, but maybe you could see if Autodesk Bentley or SBS would want to sponsor something like that, because we're going to have to use one of the programs to do this, and it'd be a great way to show the collaboration between the physical and the civil programs that one of them have.
I'd take a different approach and say we have to use all of them and whichever one produces the best product, that's the one we promote at the consortium.
I
Oh, we
would
gotta
say we
stay
do all of them
agnostic,
and
though.
not promote any of them. Just here's the pros and cons of them.
Exactly. Yeah, you can show, well, it's working well, or maybe there are some difficulties on doing this step on this specific software, and I mean that people can take the decision. That will help utilities to even they may take decision to even move to another platform. And it's not because somebody else told them; it's because they are seeing it and they have some evidence now.
Yeah.
It's a neutral approach.
Yeah. All right. I'm
You're
going to
gonna
set up a call
yeah.
to talk about just this. But we'll regroup on another call and let's discuss it further. Make sure we can get the right people from the consortium. I love the idea, and I think it's something that's always been done. You want to benchmark AI on hardware, you use all the hardware and you try it on everything and see which one's the best, right? So, yeah, let's try to get some buy-in, and I think the number one thing will be getting the vendors to participate, because I guarantee right now I can know one of them that'll have a hard time doing anything for us. So, as always.
Yep.
But that's
Actually,
fine. All right.
that will help them to improve too.
Yeah. No, it's a great way to compare them. And like you said,
Yeah.
it's open, right? I mean, yeah.
And depending on which one you're talking about, like I know we have different relationships with different vendors. So we can leverage our own, like, hey, we
Yeah.
would like you to go and participate in this. Please do.
Yeah.
Throw more weight behind it from different utilities and contractors and all that stuff. Okay.
Yeah. That's great. Well, I know that Anthony and I will be having a vendor meeting at the bar down in Chattanooga. So that's step one. Let's let's close out with a little talk about, really futuristic stuff. So that, I look at quantum computing, blockchain. I've been playing with Microsoft Q Sharp, which is a quantum computing language. And I saw this thing of quantum neural networks that are coming. And, to Anthony's point about the next 5 years, it was scary enough to look at all the AI stuff. When you couple in quantum computing with it, the speed at which you can process data and train data, it's very scary what could come. So, Anthony, go ahead, man. I'll let you jump on that.
Yeah, it's kind of terrifying. This is pretty difficult to predict, really, because I have no idea, but I'll give it my best shot here. So, I think that once quantum computing becomes mainstream, it could have the potential to change our way of life, not just in the utility industry, but really everywhere. It has the potential to unlock all encrypted data in traditional cryptography almost immediately. And as a result, I think there could be a potential push towards, the opposite direction, right? Where in-person human interaction will be more valuable, as transferring secure data over public networks such as the cloud will be a massive risk initially. As far as like blockchain's concerned, right? Quantum computing could break that encryption there too, rendering it useless. So, I'm not confident traditional blockchain methods will be used, at least at first, in the utility industry. But that being said, there are some post-quantum cryptography methods. And I'm not a cryptography engineer at all, but from what I've seen, there are methods that are hard for quantum computers to break, such as this lattice-based cryptography. But until systems are updated to these new methods, everything is vulnerable to everything but physical transfer of data. So, if it's used in a utility, I could see it being used in air-gapped networks to provide insight to human operators. And utility networks are already air-gapped anyway, so that could be an option there. If we look at historically, how technology has advanced, I think these systems could replace traditional microprocessor-based relays we see now, reducing the number of components. Just like how an SCL relay can replace multiple electromechanical relays. The same could be possible with a quantum-based processing system in the future in relation to our currently installed SCLs, right? They could replace all of these microprocessor relays, possibly monitoring an entire service territory, instead of having our currently interconnected, silent network of SCLs across each substation. So really, really a lot of wild predictions there, but the potential is huge, especially coupled with AI.
Yeah, it's pretty scary. I mean, you can look it up, but I read that, the protein folding sequence that, humans, it takes scientists like, I don't know, months to do one, and they put that Google AI quantum computer on it, and it did like 80 of them in a month or so. I mean, it gets insane. And it's one of those scary things that it really, you try to predict what's coming, and who the hell knows when you couple in some of that stuff. It's kind of
Yeah.
scary. All right, gents, anybody want to close out with anything here? We've got a couple of minutes left. You want to shut it down? Last episode of 3. I thank for all your time, man. It was awesome having you all on. Lots of good discussion. So anybody want to close it out? Go ahead.
Trevor, I would just like to say, thanks for the opportunity to come on here and talk with you guys. All of y'all, it has been a real joy to be on these episodes and really kind of hear everybody else's perspectives, especially, I come from the engineering side, and we're covering a lot of ground as far as professional areas within what we do on a day-to-day basis. I mean, Shawn's coming at it from kind of software development side of things. Trevor, you and Anthony, similar situation, but from the third party side of things. Ben and I both in the contracting as well as, Michael. I think we come at this from a lot of different angles, and I think it's been really great to really talk through some of how's AI and just even not just AI, but automation going to impact the utility industry. And as far as I can tell, there's really kind of not an end in sight with regards to what kind of impacts technology and automation are going to have. One thing I will note as just kind of a closing note to any listener out there, I'm on the engineering side of things. So the one thing I would definitely encourage you when you're looking at not just AI, but the umbrella of automation, which is where AI, in my opinion, falls underneath. There's a lot of tools, not just AI, that are in that realm, that are underneath that umbrella. Don't limit yourself to just AI. It definitely be focused and cognizant of how does AI work, how can I implement AI, and how can I incorporate AI in my other automation tools. But don't silo yourself exclusively to specific or singular process platforms or softwares when it comes to automation. And every time you kind of think about these automations, we mentioned earlier, every manager's got ROI on their minds. If you're at the engineering level and you're not managing, encourage yourself to think about that ROI the second you start to go for that shiny object. Trevor, you mentioned a couple times, with so much excitement and so much movement going on in this industry and outside this industry, it's super easy to get caught up in just that kind of shiny object that's right in your face right this second. And right now, whether that be DeepSeek or whether that be Rhino and Grasshopper or Revit and Dynamo, just think about practically, what can I do to make this a practical return on investment for my company in somewhat near terms? Because most companies, most managers will be receptive to, hey, it's not going to be an ROI the first year, but year 2, this is a huge jump and it opens a lot of doors.
Awesome. Thanks, Cory. That's great. Anybody else want to close anything out with? No?
Yeah, I wanted to say something real quick that Cory mentioned. There is so much opportunity in the technology space in this industry that is completely
Still there, Shawn?
hidden. Yeah, can y'all hear me?
He's talking.
Yeah.
Yep.
Yes.
So, that if you are a tech person that is looking to do high technology, really in-depth stuff, there is room for you in the utility industry, especially if you're willing to go and learn on the design side what the designers do, because it'll take you 1 month to figure out enough about these tools to realize that there's 1,000 things we can do to make it better for our people. So y'all need to quit that sissying and get on in here, because there's more work than we're going to have an opportunity to do, certainly before I retire. So
At least in
said.
our industry, or at least from my perspective, innovation has become no longer a scary term, but something everyone seems to be striving for. So at least from my perspective, finding those new things and finding ways to improve everyday processes and procedures, not just the design, has been encouraged across the board. So I'll echo whatever Shawn and Cory were just saying, as far as if you're excited about technology, there's plenty of room for improvement here with lots of low-hanging fruit for people to come and pick.
Yeah.
So
Another quick soundbite here. If you were working in the AEC industry and doing stuff in the AEC industry with BIM and all of that, the utility industry is 5 to 7 years behind you. So you can take all of that experience that you had in the AEC industry, come plop it down in our industry and make a real impact. So seriously, get in here.
Awesome.
Yep.
Go ahead, Michael. You want to close it out with something?
I don't have, you know me, I'm bad at on the spot stuff.
No worries, man. Anthony?
Well, yeah, I'll take it a little bit of a different direction here. I think I want to express the vision of hope here, right? I hope that AI remains an augmentative technology for humans, right? And not a replacive technology. Everybody is kind of terrified that AI is going to take their job, and rightfully so, right? The unknown that we talked about is pretty terrifying, especially when you combine it with quantum computing. So, I hope that AI remains augmentative to humans. It replaces all of the stuff that we don't want to do. It allows us to do what we do want to do. And that's really all I have to say.
No, that's great, Anthony. Josue, you want to close us out, man?
Well, you guys already say it everything. So no, I think that this was probably one of the 3 episodes that I liked it the most. I think was extremely interesting. There is a lot of meat from this one that I already took some notes, and I think it will will be very helpful to keep the conversation going. It will be very helpful for utilities and other partners in the engineering firms in the utility industry that maybe are looking into what's going on with the AI and this really can help us on this. Well, it's this is a right place to start hearing. And maybe if you are in the substation, electric utility industry substation side, this will help you to maybe take any decision that you may be planning to. So thank you to everybody.
Yeah, well said, Josue. Thank you so much. And thank you all. I appreciate everybody. And yeah, for all the listeners out there, all these guys are some of the most innovative people we have in the SDSIC. So feel free to reach out. I'll put all your bios and links in the episode. So that closes out 3. I think we're gonna have to do another one probably in a month or 2 because this stuff keeps changing. As Josue just said. So
yeah,
appreciate all you guys, man. Thanks for joining us.
Thank you. Thank you.
Thank you for listening to the Power Up Podcast today. If you enjoyed this conversation and you're not yet a member of the SDSIC, join for free at sdsconsortium.com. Be part of the community and all these great conversations. And maybe you'll be the next guest on the Power Up Podcast.